Steep turns. Steep turns are a private and commercial maneuver involving one or usually two 360-degree turns in opposite directions, 45 degrees of bank for private and 50 degrees of bank for commercial. We're maintaining a constant airspeed and altitude throughout this maneuver. First, we got to be able to read and understand what's going on our attitude indicator. So these markings at the top are most useful for steep turns because they are what denote the amount of bank our aircraft is in 10-degree increments. So we've got 0, 10, 20, 30, then from 30 to 60 and 90. So for private level steep turns, we're looking for 45 degrees of bank, which means we want to line this orange marker up halfway in between our 60 and 30 degree hash marks. Okay. Next, let's talk a little bit about the aerodynamics and the difference between straight and level flight and turns. So we know with straight and level unaccelerated flight, we've got four equally opposing forces. In this case, this aircraft is holding its altitude. So if that was true, then the lift would be equal to the weight. And if it's holding its airspeed, the thrust would be equal to the drag. But things change a little bit when we get into a bank. So in this case, we've banked to the left. So our right aileron has been deflected downwards. Our left aileron has been deflected upwards. And this vertical component of lift has been transferred or transformed into a horizontal component of lift now. The force that pulls our aircraft laterally around our turn. So meanwhile, that our vertical has lessened, our weight has stayed the same. So these two forces are no longer equal, and our weight can overcome our vertical lift, so we get a descent. Okay, unless we increase the total amount of lift that we're creating by increasing our angle of attack and increasing back pressure on our yoke. So let's say we do that to be able to maintain our altitude. Good. We've increased our total amount of lift, but we know that when we increase lift, we also increase drag. So we're going to slow down, which is not what we want. So we got to put in power to be able to not slow down. So those two things, we got to do power adjustments and pitch adjustments to be able to maintain our airspeed and altitude in a bank, especially a steep bank, like a steep turn. So let's get into the setup, the execution, and the standards for steep turns. This maneuver calls for no less than 1,500 feet AGL, and we want to use 500-foot increments. We're going to use a suitable area to execute the maneuver. We're going to do clearing turns, make sure there's no other traffic in the area, and that there's no other obstacles or obstructions like towers or mountains. And we're also checking the viability of our fields to see if we can use them for forced landing if necessary. If we lose our engine, we got to be able to safely land. We're setting up for cruise, getting trimmed out, and looking for 95 knots at 2100 or 2200 RPM is normally the power setting that'll do the trick in a Cessna 172. And we're choosing a visual reference, something prominent like a lake or a town, something that we can reference visually during the maneuver to be able to maintain situational awareness. Okay, so we've done all this setup stuff, we've done our clearing turns, we've made our radio calls to the practice area, and we're lined up with our visual reference 12 o'clock, and we roll into our left turn. So we're on our way to 45 degrees of bank for private, 50 for commercial, and passing through 30 degrees of bank, we're going to increase power by a couple hundred RPM, and we're going to increase back pressure enough to be able to maintain our altitude. We're also, once we lock in that 45 degrees of bank, we can use our trim to relieve that control pressure. 2 full swings of the trim wheel will normally do the trick. And then we're looking outside at our sight picture. So Um, Side picture I was going to draw, but it was kind of tough and I ran out of room. So here is a picture of what you can expect with a sight picture in a light aircraft for steep turns. So um, a left turn from the left seat perspective. I wish this picture had the cowling visible because I like to use the rivets. So in a left turn, you want to drag that row of rivets, that left row of rivets through the horizon. And then in a right turn, you'd want to drag the left edge of the cowling along the horizon or just below the horizon. That's the thing. Depending on how tall you are, the sight picture is going to be different for everybody. So tall person's sight picture is going to look different than a short person's. So the best thing to do is just look at your sight picture and look at what kind of sight picture gives you a constant altitude, and then use that sight picture. So we're looking outside 90% of the time. The other 10% of the time, we're coming inside to check our instruments. So that's a huge part of this maneuver is being able to detect and correct for deviations from our airspeeds and our altitudes. So let's say, for example, we see that we're losing altitude. Uh, it would not be a bad idea at that point to check your attitude indicator. Maybe the reason why you're losing altitude is because you got too much bank in. If that's the case, then you just bring the bank back out to where it's supposed to be, and you'll stop losing altitude. Um, or let's say you lose an altitude, you check your attitude indicator, and it turns out it's exactly where it's supposed to be. Well, then you'll need some back pressure. So you put in that back pressure, and if you put that in, you'll get your altitude back, but you'll probably observe a decrease in airspeed. In which case you'll need to increase power to get your airspeed back. So it's a juggling act. If you change one thing, you'll probably have to change the other. Um, but some people say that the ability for the the ability of a pilot to be able to correct for the altitude and airspeed deviations is more telling than someone just getting lucky and nailing their altitude all the way around. It shows a lot of skill to be able to recognize and correct for these things. So, oh yeah, I forgot to mention to be able to maintain your 45 degrees of bank, you have to have opposite aileron in. So this is due to a thing called overbanking tendency. So I'll use my model to demonstrate that. All right, so what this is the further past about 30 degrees of bank you get, the more the aircraft's going to want to overbank on its own with neutral controls. So you got to use opposite aileron. The reason why this happens is because when you're in a turn like this, the uh, the wing on the outside of the turn is moving through the air faster and creating more lift than the inside wing. So overbanking tendency, and also adverse yaw is kind of the same thing. It's creating more lift, thus more drag. So you're going to be slipping unless you put in the appropriate amount of rudder. All right, so coming around about 2/3 to 3/4 of the way through our turn, we're looking over our left shoulder, we're spotting our visual reference, and timing our rollout such that we roll wings level on our heading. Okay, but when we come out of that bank towards wings level, we want to passing through 30 degrees again. We want to bring that power back out to where it was when we started, and we want to we'll relieve the back pressure. So relax on the control pressure, or bring that trim out so we don't balloon up. And then we continue, same thing to the right, except we're going to be using more right rudder because of the left turning tendencies and torque and the turning tendencies. So standards for the maneuver, we got to clear the area, airspeed below maneuvering speed, 45 degrees of bank for private, 50 degrees of bank for commercial, altitude plus or minus 100 feet, airspeed plus or minus 10 knots, bank plus or minus 10 degrees, and heading plus or minus 10 degrees from our rollout heading from where we started. And that is steep turns.